Hello, Tech House viewers. Hello, and welcome to this presentation on space weather and its potential impact on modern technology. Space weather is a term used to describe the conditions in space that can affect technology on Earth, including satellites, power grids, and communication systems. In this video, we will explore the causes of space weather, the potential risks it poses to modern technology, and how we can prepare for the worst-case scenario. Part 1. Understanding space weather. Space weather is caused by the activity of the Sun, which is a massive ball of plasma that generates powerful magnetic fields. These magnetic fields create sunspots, which are dark areas on the Sun's surface that are cooler than the surrounding areas. Sunspots can lead to solar flares and coronal mass ejections (CME), which are massive explosions of plasma and magnetic energy that can be directed towards Earth. CME can cause geomagnetic storms when they interact with Earth's magnetic field, which can lead to a range of effects on technology. Some of the most common effects of geomagnetic storms include power grid outages. Geomagnetic storms can cause power surges that can damage transformers and other electrical equipment, leading to widespread blackouts. Satellite damage. Geomagnetic storms can cause charged particles to accumulate in satellite electronics, leading to equipment failure. Communication disruptions. Geomagnetic storms can interfere with radio communications, including those used by airplanes and ships. Radiation hazards. Geomagnetic storms can increase the amount of ionizing radiation that reaches Earth, which can pose a hazard to astronauts and people in high-altitude flights. Part 2. The Carrington event and other historical space weather events. The most powerful space weather event in recorded history is the Carrington event, which occurred in September 1859. This event was caused by a massive CME that hit Earth's magnetosphere, causing auroras to be visible as far south as the Caribbean. The Carrington event also caused widespread telegraph disruptions and electrical fires, which were some of the first signs of the potential dangers of space weather. Since the Carrington event, there have been several other significant space weather events, including a solar storm in 1921 that caused widespread telegraph disruptions and electrical fires, as well as a geomagnetic storm in 1989 that caused a power grid outage in Quebec, Canada. Part 3. Potential impact of future space weather events. While we have made significant advancements in our ability to detect and forecast space weather events, there is still much that is unknown about the potential impact of future events. One of the biggest concerns is the potential for a catastrophic space weather event that could cause widespread damage to modern technology and infrastructure. Experts predict that the likelihood of such an event occurring in the next 100 years is around 12%, which may seem like a small probability, but the potential impact is so great that it is a serious concern. A catastrophic space weather event could cause widespread power outages that could last for weeks or even months, as well as disrupt communication systems and damage satellites and other critical infrastructure. Part 4. Preparing for the worst-case scenario. Given the potential risks posed by space weather, it is important that we take steps to prepare for the worst-case scenario. Here are some of the key steps that we can take to minimize the impact of a catastrophic space weather event. Developing early warning systems. By developing early warning systems for space weather events, we can help minimize the impact of these events by giving people time to prepare. This can include monitoring the activity of the sun and issuing alerts to people in affected areas. Building resilient infrastructure. We can also take steps to build infrastructure that is more resilient to space weather events. This can include reinforcing power grids and other critical infrastructure to prevent damage from power surges and other effects of geomagnetic storms. Improving space weather modeling. One of the key challenges in preparing for space weather events is the uncertainty surrounding their potential impact. By improving our models of space weather and the potential impact on technology, we can better prepare for the worst-case scenario. Developing backup systems. In the event of a catastrophic space weather event, it may be necessary to rely on backup systems to maintain critical infrastructure. This can include backup power sources and communication systems that are not reliant on satellites or other vulnerable infrastructure. Part 5. Conclusion. In conclusion, space weather is a serious concern that has the potential to disrupt modern technology and infrastructure. While the likelihood of a catastrophic space weather event may be relatively small, the potential impact is so great that it is important that we take steps to prepare for the worst-case scenario. By developing early warning systems, building resilient infrastructure, improving space weather modeling, and developing backup systems, we can help minimize the impact of space weather events and ensure that our critical infrastructure remains operational in the face of potential disruptions. As we continue to rely more and more on technology, it is essential that we take steps to safeguard against potential threats, including those posed by space weather. By working together and taking a proactive approach to space weather preparedness, we can help ensure that we are able to weather any storm that comes our way. Thank you for watching, and stay safe.